I hope you're recording. Okay. So let's get started. Hello people. My name is Muhammad Sajir. I'm doing my PhD at IIC Bangalore, which you can see in the figure, which is IIC Bangalore. And I'm doing my PhD here. So in this series, we will be discussing different problems that has been asked in the previous years. We'll be discussing problem from CSIR NET exam. We'll be discussing problem from GATE exam. We'll be discussing problem from JAM, JUST, and everything, or CUSET or any other exams. Okay, so you will get an idea of uh, where exactly these problems are asked, or what are the important topics we have to study, what are the important tricks, tips, what are the equations we have to by heart, and everything. So in the today we will discuss three problems that has been asked in NET Physics June 2020. So these three simple problems, one from mathematical physics, other two some from electrostatics. So this will help you to get an idea of getting the problem solving skills started, and which you will definitely improve in the later point of time as you practice. So let's move to the problem. So here is the one problem from mathematical physics. It's actually basically from matrix. So the question is like the eigenvalue of 3 by 3 matrix is this 3 by 3 matrix. We have to find the eigenvalue. From the eigenvalue, we have to see which options, A or B or C, which one is obeying that eigenvalue, and then we can take it. You may have studied a matrix from +2. I mean, you started studying matrix from +2, and I know you all have a good idea about matrices. You know how to solve this problem. But in any entrance exam, the basic thing you need to solve the problem as fast as you can possible. So there are some tips. So if in this case, don't go to try these methods to find the eigenvalue of this matrix. We'll just substitute this A, B, C equal to 1. Then the matrix will be changed to A square 1, AB1, AC1, AB1, B square 1, BC1, AC, BC all are 1. So now we have our matrix as a 3 by 3 matrix with one, all elements are 1. So there is a rule. There's a rule, or we can say it's a tip. So if we have a n by n matrix, here we have 3 by 3 matrix, or if we have generally if we have a n by n matrix, if its all elements are 0, having all elements equal to 1, then its eigenvalue will be n 0 0 0. Okay, this is a rule. So if we have a here you can see you have a 3 by 3 matrix, all elements are 1. So your eigenvalue will be, so your eigenvalue will be 1, no, 3 0 0. Am I right? Check. Right, because so if you have a, for example, if you have a 4 by 4 matrix, what will be the eigenvalue? 4 0 0 0. We'll have n minus 1 zeros and the value of n as eigenvalue. Now we will check which of the option is correct. So you just start from A. If you see, since our A, B, C equal to 1, A square plus B square plus C square will be 1 plus 1 plus 1 will be equal to 3. So 3 0 0. This is the correct option. Ticked. So if you already know this trick, you don't need you just need at least 30 seconds to solve a problem. So you'll have, you have scored 2 marks for this, right? So in net you have as you know, you have 3 parts: A, B, C parts. B have 2 marks and C have 5 marks. So in B, like if you know just equations and everything, you will be able to solve the problem and you get the solution. In C, you will need some more deeper understanding of the theory. Then you will be able to solve for 5 marks. So that's how, that's how it works. So This is about the agent value problem. I think you all may have got it. If you have any doubts or things, you can just ask me in the comments. Or if you, I mean, for every problem, what we do is instead of just solving one problem and saying one tip, if there is a problem from matrix, we will look into what are other short tricks, other tricks and tips in the matrix if for any problem. So let's get let me give you a brief idea about the matrix and some important tips and tricks. I expect you already have a basic knowledge in matrix. You know what is an n-band matrix. You know what is symmetric matrix. What you know what is q-symmetric matrix. Or even if you don't know, let me just explain it in a very faster way. So you have a there are matrices, different kind of matrices. If you have a symmetric matrix, it is should be A transpose equal to A. You know transpose, right? If you have a 1, 2, 3, 4, 5, 6, 7, 8, 9 a matrix. If you want to take transpose of it, what you will do? What you will do is you will change all the rows to columns. All the rows to the column. So here your 1, 2, 3 will be changed to first column. Here 4, 5, 6 will be changed to second column. Here 7, 8, 9 will be changed to third column. That's a transpose. That's how we do transpose. So if A and A transpose are same, these are called as symmetric matrix. For other example, we have a skew symmetric matrix. In skew symmetric matrix, what will do? Say A transpose will be equal to minus A. That's it. Okay. And there is something called Hermitian matrix. These are the most common matrix things they will be asked in the exams. So if you have some idea, it will be helpful. In it will be A dagger equal to A. What is dagger? Dagger is usually represent dagger. It is actually, if you have matrix, we will first take the transpose, then take the conjugate of it. Then it will be a dagger matrix. Conjugate means if you have a 5y in the matrix, when we take conjugate, it will become 5 minus 5y. And transpose is as we discussed it here. That's about the Hermitian matrix. And let me just clean this. Okay, Hermitian matrix. So these are the common matrices, and there are usually there are some other tricks. For example, we have a unity matrix. Unity matrix, what will happen is A into A dagger should be equal to A dagger into A. That should be equal to I, identity matrix. Identity matrix, you know, right? 1 0 0 0 1 0 0 0 1. That is a 3 by 3 identity matrix. And you can write 4 by 4, 1 by 2 by 2 or anything. Okay. So this is called as unity matrix. So we also have something called orthogonal matrix. Orthogonal matrix. Orthogonal matrix, what will happen is we will take the transpose. A into A transpose equal to A transpose into A equal to I. The unity matrix, it is dagger. Here it is transpose. That's it. So that is the most important matrix types in matrices. Like most of the time, these problems will be asked from these areas. There are some general rules, like for example, there are other tricks. For example, if you want to, if A is a matrix, if I say A is a matrix, and if I ask you to find the determinant of e power A is a matrix, you should remember. E is exponential, right? So it's an equation. It is equal to a trace of A. Is another formula that usually they ask. You know what is trace, right? So trace is like the sum of the diagonal elements. Here the trace will be 1 plus 1 plus 1 is equal to 3. And you, of course, you know how you find the determinant, right? So that's about that thing. And maybe a few more, for example, if we have singular matrix, if you have singular matrix, in singular matrix, determinant of that matrix should be 0. That's about that we mean when we say it's a singular matrix. And there are a lot of general rules. Trace of A when A and B are matrices, trace of A and B should be equal to trace of B and A. right? Then if you have A is a Hermitian matrix, Hermitian, then IA and minus IA are skew Hermitian. And about eigenvalue, if you have any matrix A and if you take the transpose of it, same, both will have same eigenvalues. So if you take a transpose, the eigenvalue of the matrix won't change. The eigenvalue is a value we can say which is a single number which represent a entire matrix. Say a single number which represent a entire matrix. So that is a common thing about matrices. And one more thing is like most of the cases in mathematics questions repeat or the concepts are repeated. For example, the one we have solved here, this one is asked in NET June 2020. The same problem, or not same problem, but the same concept has been asked in CSIR. I think June or December. I think June 2011. They asked this 2020, 2011. So if you have already solved this question, you know, okay, this is asked, this has been asked, this has always solved. You can just stick in when, I mean, in 15 seconds you'll be solved and you'll be moved to other problems. Because in part C you need more time, so you'll have to solve the problems in part B as fast as possible. You'll have 3 hours, as you know, in the CSIR exercise. So yeah, I think that's about this problem, and we already look into just few concepts. And as further we know the classes, I mean, as we discuss more problems, I will be discussing more tips in matrices. So I think this is enough for the this problem. And let's go to other problem, another second problem. This also asked in June 2020. This is from electrostatics. So whenever you get a problem, try to make a draw a figure or something, whatever you can easily look into it later. For example, here you have 3-point charges Q are placed at the corners of an equilateral triangle. So you have an equilateral triangle. Equilateral triangle means a triangle having, I mean, all the sides have equal length. For example, if its length is A, I will make a bigger picture like this. Okay. If your size length is A, should be A and it should be also A, right? Then another point charge is placed minus Q. Okay, we have 3-point charges placed at the corners of a triangle. Q here, Q here, Q here. Another point charge minus Q is placed at the centroid of the triangle. So we have the centroid, you know, right? The centroid of, for example, centroid will be like something somewhere here. Okay, it's minus Q. We draw centroid. We'll do perpendicular to the corners, and that point will get centroid. Okay, I will just remove this part. Okay. Okay, this is centroid, and we have minus Q charge here, right? So we are saying that if the force on each of the charges Q vanishes, so the force on this charge or this charge or this charge are 0, then what they want to know is then the ratio of Q by Q. We want to find what is Q by Q if the force charge vanishes. So of course, if you want to find the force, you know, electrostatic force equation, right? Force is equal to 1 by 4 pi epsilon 0 q1 q2 by r square. So here I will just name it. I will just name the things. I'll name it A. I will name it G. I will name it D. Okay. So if you want to find the force from minus Q to a point A, minus Q to charge Q, we want to know the distance first. So we want to find what is AG first. So AG is basically AD minus GD, right? AD minus GD. And now we want to know what is GD. So we know for a equilateral triangle, for any equilateral triangle, for any equilateral triangle, for example, we have DG. For any equilateral triangle, the TG will be 1 by 3 of the total length. This is true for any equilateral triangle. The centroid length, this point. Change the color green. Okay, this point. This length will be equal to 1 by 3 of the total length. 1 by 3 of the total length. That's the rule. I just okay, fine. Okay, so that's a rule. So we know what is AD, right? Because AD will be because it is a triangle. I mean, triangle. You can use the Pythagoras theorem and you can find the AD. So AD will be what? Root of a square minus a by 2 whole square, because this is a by 2, this is a by 2, and this is a. So root of a square minus a by 2 whole square. What will come? We'll take a outside, we'll take 1 minus 1 by 4. This will become into root of 3 by 4. I'll be root 3a by 2. That is AD. Okay. Now, that is AD. Now, DG will be equal to what? 1 by 3 of root 3a by 2. Then the top root 3 and the under root 3 will cut. So we will have a by 2 root 3. A by 2 root 3 or wait, I think we made some mistake. AD we have find out, then DGs we have find out. A by 2 root 3, it is DG. Now we want AG, right? AG equal to AD minus GD. What is AD? Root 3 a by 2 minus DG a by 2 root 3. A by 2 root 3. Now we'll take it out. Root 3 by 2 minus 1 by 2 root 3. That will come how much? We'll take the a by 2 outside. Root 3 minus 1 by root 3. It will be equal to a by 2. 3 minus 1 by root 3 equal to a by root 3. Okay. So we have found out DG, AG also. AG is actually 1 a by root 3. I will just remove all this. Now I hope you got it. What is AG? AG is a by root 3, right? I will rub it off all the other things. Yeah. If you are also trying to solve this problem, just pause this video and try to solve first, and then you will get an idea of where you are going wrong and how I am solving it. Then this will definitely help you to understand this problem more clearly. Okay, we got the AG. Now we have to find the force, right? Now I will redraw the triangle here. So it will be easy for you to understand. Sorry. Let's go here. Q here, Q here, Q here. So the electrostatic force between this Q and this Q will be in this direction. Electrostatic force between this Q and this Q will be in this direction. And this is a minus charge, so this will be in this direction. Maybe I can use another color. This and this. Since it is equilateral triangle, this will be also 30 degree. This is also 30 degree, right? Both will be 30 degree. Now let's see if I say as you know in the questions, as they have mentioned that the force on the charge Q is charge Q vanishes, so it should be 0. So I will just write the force equation at that this Q. So force equal to 1 by 4 pi epsilon 0 Q square by a square. This distance is a, this distance is a, this is a. So Q square by a square. And since it is clear to cancel, this force is vector, we have to find what are the force cancelling this down force from the up. So this since is 30 degree, the component of this will be cos 30, right? Cos 30 degree. Then again, look into this q and this q, it will be also q square by a square cos 30 degree. That should be equal to the force which is minus q and this q. So which is equal to 1 by 4 pi epsilon 0 q into q divided by what's the distance, this distance, you know, right? We already measured in the last one, a by root 3, you know, right? So a by root 3 whole square. Okay, now we since we have 1 by 4 by 0 everywhere, we'll cut it. We have 1 q everywhere, so we'll cut it. And we have a square everywhere, we'll cut it. Okay, cut it. And what is cos 30? Root 3 by 2, right? So q into root 3 by 2 plus q into root 3 by 2 equal to q by a into root 3 square, just 3, q by 3. Okay. Now if we take the q by q, all the q to right side and all other value to the left side, so 3a root 3 by 2 plus 3a root 3 by 2. Or it is twice, right? So 3a root 3, 3a root 3. But a should also cancel, right? A square, a square. Yeah, this is already cancelled, so we shouldn't put root 3 here, a here. Is this right? We'll have it root 3. Somewhere I guess I made a problem mistake. Root 3 by 2. Root 3 by 2. We have q yeah, correct. This is division, right? I have put in a multiplication here. So this 3 will actually go up, right? So yeah. So this are you. Okay. So this is one thing you have to be remember in your problem. While we solving a problem, I mean, just a small mistake will you put you in big trouble. So now I will just rub it off and we will look again. So now we have we'll change all this q from left side to right side, q by q, and take all the other value to the left side. So it is root 3 by this a is also we have cut, yeah, also we have cut root 3 by 2 by 3 plus root 3 by 2 by 3 and root 3, then we'll cut 2 times, since it 2 times 2 will be off, then root 3 will be off, so it will be 1 by root 3. So solution q by q equal 1 by root 3. Is it there in this 1 by root 3? Yeah, it's B. This is a simple problem, right? If you know electrostatics, these are the, I mean, just it won't take more than 1 minute. You have to be fast, you have to practice a problem, and then you can easily do it. And only the thing you maybe forgot that the centroid of a triangle can be written as the 1 by 3 of AD. For this DG length can be written as 1 by 3 of this entire length. That you may have forgotten. So you will have to, I mean, remember all these things. These are the basic stuff. We should all know. I mean, while we solving problem, we will be entire. I mean, we will. I mean, we will learn all this again. I mean, this kind of problem they will ask in, I mean, other exams also, so you'll know. So let's look into the third problem. I think this is enough. This, yeah. So this one, it is also asked in June 2020. if you look at this problem, these are very easy. If you know the concept, like you can just ace it. So I mean, NET is not a hard exam. Like, how much you prepare and how well you prepare, then you can easily crack it. Okay. So we have here we have three infinite long wires, each carrying equal current, are placed in the xy plane along x equal to 0 plus d minus d on the xy plane. So we have, I will just draw the xy plane. We have three infinite long wires. I will just represent like this. Okay. One is in minus d, another one is in plus d, another one is in 0. Okay, 0 plus d minus d. So then we have to find where the magnetic field vanishes. Correct. The long wire each carrying equal current. I'll take just write the number 1. This is the second one. This is third one. So we'll have to put a, I mean, somewhere x and find. I have to find out what is the magnetic field there. Then you will be easily able to get it. Okay. So I will just put x's here somewhere, maybe here. Okay, this point. I'll just call it as x. This is the point. At this point, I will find the magnetic field at this point due to this wire, this wire, this wire, and I will. So magnetic field should vanish. So for example, magnetic field of 1 plus 2 should be equal to 3. That is simple equation, right? B1 plus B2 should be equal to B3. B is used the, I mean, B is we usually use it to represent the magnetic field. So you may have studied magnetic field due to a wire. Magnetic field due to a wire is equal to mu 0 I by 2 pi r. It's a general equation you have to know. There are a lot of other kind of equations for each structure. For maybe if you have studied the Griffith electrodynamics, there is for example sheet of charges, or there is I mean there for line of charges, or for each of them there is some equation that you have to know. You may have use, you can also use the Gauss law and find out each of these values. That's not a hard thing. Okay, then let's do the problem. So we'll, for example, so B1, we know B1, B is equal to, B1 is equal to mu 0 I by 2 pi. How much is the distance? Distance is d plus x, right? Or d minus x. The distance is d plus x. Okay, but it's B2. B2 is at the center. I mean, this is the line. The wire is at the center. So mu 0 I by 2 pi into x should be equal to mu 0 I by 2 pi into the distance is total d, so d minus x. So if you solve this equation, you will easily get it. So we know, like, so mu 0 is common, I is common, so you can all cut everything, and 2 pi is common. So like, I'll change other color. This is common, this is common. Then you can just cut and you can write like this, 1 plus d plus x, 1 by x equal to 1 by d minus x. So now you have to solve this and find out what is x. Easy. So how will you do that? You just keep it and you just do it as x plus d plus x divided by x into d plus x unit equal to 1 by d minus x. Then again we will take d minus x to left and d plus x to right. So x into d minus x plus d plus x into d minus x equal to x into d plus x. Okay. Now we'll have to solve this. D minus x into d plus x is d square plus x square that we know. And x is xt minus x square. That x square and this x square will cancel. And so we can write it as d square plus xd minus 2x square should be equal to dx plus x square, right? Then again, this one we will write again. Then it will come as 3x square equal to d square, and this can be written as is equal to plus or minus d by root 3. So if we check if we have the solution is there, yeah, d by root 3 is also d upon. If you know this equation, it won't take more than more than 1 minute to solve this problem and get the solution. So we have solved 3 problems today, and on the consecutive videos we'll be solving more. So that's it.